working as an principal architect with the tech sales BU. People who do not know tech sales, it's a department where we kind of convince our customers to use and adopt open source technologies and data solutions. Other speaker, Shailendra?
Yeah, myself, Shailendra. I'm an architect at Red Hat.
Awesome. So, just let me address this. Yeah. So I think today what we want to do is we will like to cover a very important topic around sustainability. If you were around at the keynote, you would have seen Vincent talking about something which is not AI for a change. And he was talking about sustainability. He was talking about the climate change. And I believe that today's this particular topic is kind of enlightening. It was for me when I was trying to prepare for it. I hope you guys also figure out what are the key things in here. So we will cover basically the sustainability, what are the key concerns, and how CNCF is building the whole solutions and guidance to make it happen. And one of the key projects in that space is Kepler. We will introduce that Kepler. So this whole session going to be like 101 on Kepler. People who are from Red Hat, this is part of our OpenShift solution as well. So you can actually learn about it and then present it back to our customers, right? And apart from that, we'll double click on the architecture part of it. You will see what are the moving pieces of Kepler as an architecture. And then towards the end, we'll talk about different deployment options available with Kepler. And Shailendra will actually demonstrate it live, right? So we have a DevConf, we need to have a live demonstration, right? So yeah, just to set the stage first, I just want to check like how many in the room here are from Red Hat? Oh, okay, almost 50%, fantastic. And people who are not from Red Hat, are you guys students or from other companies? Okay, okay. So just maybe my quick couple of questions on this. So of course, Red Hatters, I'm sure you guys are already working with OpenShift and Kubernetes, I believe, right? So perfect. And so in that Kubernetes, you must be deploying your VMs, containers, pods. Those are the de factos, right? Question to everybody, how many of you actually understand that the application that you're running, whether containerized application or a VM, what is the carbon footprint of that workload? Just raise your hand if you actually know, track, or do anything about that. All right, so the answer is absolutely 0%, right? So probably this whole session gonna help you with that. By the way, most of the people that I see here from Red Hat, you guys are aware, right, that most of the C levels, they do have a dedicated commitment on carbon neutralization by some years, right? So this is a good point what we learned today. We can take it back to the C-level and the directors, especially on the infrastructure side, and present them that this actually helps in the real life, right? And by the way, this is already productized. It is available as a part of OpenShift. All right. Okay, so just to set the stage here, sustainability is something that needs no introduction. It is pretty much it's very intuitive, but I think a lot of companies have taken a different approach to it. One of the things which I like about is the definition given by HP, Hewlett-Packard. What they say is that sustainability in an IT organization is all about creating the innovative products which doesn't deplete the natural resources. Now, eventually, I'm going to talk about what those natural resources are and how it is being tracked and how we can help to mitigate those things, right? So special thanks to IBM here because a lot of work has been gone in last 3 to 4 years from IBM research and IBM business value team. A lot of insight has been shared, and the slide deck that you see here, more or less the similar data has been presented last 2 to 3 years in the space of sustainability quite consistently, right? So, and this data remains even relevant today as well, right? I think what I would like to have a takeaway from this is that sustainability is something that always has a competing priorities. On one end, you're looking at innovation, which needs a lot of compute power required. We all know how much compute power is required for the LLMs to run, right? At the same time, sustainability is something that focuses back on looking at your consumption, looking at your energy requirement, looking at what's the carbon footprint that you end up creating in the big data centers, right? So it's a kind of balancing act. That's something which this whole initiative is trying to balance it out, right? In fact, a very nice statistic I can see here is that the data centers are consuming 2 to 3% of world's energy. Just to give you a perspective, just the social media that you consume, that attributes to approximately 25 to 30 trillion megawatts of energy, which just put things to perspective. The India as a growing economy, we need a capacity of 900 gigawatts per year, and 20 times more is what we are actually investing into using social media like TikTok and YouTube and all of that, right? So that's the scale we're talking about here. So even 2 to 3% is pretty high here. Now, I think in the Paris Accord, it was well established that there is a direct connection between economical growth with your energy consumption, and it directly ties back to greenhouse gas effect, right? So greenhouse gas effect is nothing, emission is nothing else but the emission of CO2, which gets into the environment. Where it's coming from, it is but to provide those amount of energy, the natural, the fossil fuels are burned to achieve that. So there's a direct relationship between what you run in a data center with the fossil fuel which is being burned to create that energy which provides them, right? So a lot of work has gone in, in fact, the top FANG companies, they have their own targets to become net carbon neutral by 2045. Facebook has it by 50. So different companies have different. So the question here is that, so what is the solution? The solution is what you see on the screen, that the CNCF, which is Cloud Native Computing Foundation, they have a special team or special group called Technical Advisory Group, Environmental Sustainability. Now this group is actually responsible to create those, support those projects and initiatives and papers which would make sure that the carbon or environmental footprint is reduced from the data center level all the way till your application pod and pods or containers and processes, right? So, if you are looking at sustainability, you should be following TAG. There's a link that I have given along the slide, which you can read later, which will get you to look at their charters, basically, right? Now, let's get into the technology piece of it. So now, this tag has got a very well-established charter and a landscape defined. I'm sure you guys would have seen the landscape of CNCF, right? It's pretty busy picture. Now, there's a dedicated landscape being created just for sustainability, and it basically covers different aspects. They call it as dimensions. There are 4 dimensions to this landscape. The first one is the methodology, data center. I'm going from right to left. Methodologies, data center, observability tooling, and infrastructure tooling, right? Now, the very first one is the methodologies. It has got a sub-segment which it kind of gives you the mechanisms of how measurement should be carried out, how the observation should be carried out, focusing on the carbon footprint, focusing on the energy consumption, mapping it back to the application that you're trying to run, right? So I'll probably take some few examples to give you some pointers for you to see it further. The first one I would highlight is the SCI, which is a Software Carbon Intensity Standard. That's a new specification that has been written, agreed upon, and created, which focuses on how would you measure carbon footprint of any software that you run. Now, that's a new standard being written, and there's a bunch of guidance also given on that. So that's on the mechanisms of measurement. Open telemetry is something that I'm pretty sure at least Red Hatters would already know. Open telemetry is the new upcoming, I wouldn't say new, but this is one of the incubated project, and using this mechanism, you can get a lot of metrics out of your system, of your softwares, right? Whether it is monitoring data or the logging data, all of that data can come out through open telemetry. And it has got a good amount of support from leading language support as well, .NET, Python, Java as well. So that's on the methodology dimension to it. I said at the initial stage that data center is the second aspect here. There are a lot of blueprint has been being written to how a data center can be redesigned or rethought to become more carbon neutral. One of the specific things which I like the work is around the BMC telemetry. So people who understand the bare metal world, BMC is something that hosts a lot of the hardware level data, like around the fan, the temperature, the CPU memory, a bunch of data which comes out of the system. These are open source projects which would help to get the data out at the motherboard level, right? But then today's conversation is a lot about observability tool, which is right in the center. I have highlighted in the green color with Kepler. Apart from that, G profile and EcoCI is something that I was really fascinated to find. G profiler is if there are people who are in the space of writing applications. G profiler is nothing else but a profiling software, which is an open source free software, which can actually monitor and profile your application at runtime and show you that which part of your code is performing at what level, and most importantly, how much energy it is consuming with the carbon footprint. So it kind of ties it back in that space. Other one is the EcoCI, which is nothing else but a library which helps you to track your carbon footprint when you run your CI/CD pipelines, right? And that's being available on GitHub as well. So anyways, today's conversation is going to be on Kepler. Infrastructure tooling is something, so that the whole infrastructure tooling is all about that if you are able to measure your carbon footprint, but then how would you make sure that you are taking corrective actions? So measurement is one aspect, but taking corrective actions is all about infrastructure tooling, more on that towards the end, right? With that, I'll quickly introduce you to the project Kepler. This Kepler is not a NASA project. Quite a people get confused with that. Kepler stands for Kubernetes-based efficient power level exporter. It is nothing fancy. I would say that it's a bunch of matrix which gets exposed in a Prometheus format, which makes it very easy to consume for any system which is compliant to read Prometheus format, right? Example is sysdig. Prometheus as a time series database itself can do that, right? Now this open source project is currently is at a sandbox maturity level. It has been productized and made available as a part of Red Hat solution as well, which is something that Shailendra will give you a demonstration in a couple of minutes time. And this project currently has contributions from, main contributions from Red Hat, Intel, IBM, and there are a couple of universities who are involved in testing and research work as well, right? Red Hat is pretty much writing the core component of this Kepler as a tool. Intel is bringing the libraries and the architecture specific libraries to integrate with. IBM is focusing on bringing the integration and the overall architecture integration space. So I think it's a pretty active open source project. Some of the, I'm going to touch upon the moving pieces inside Kepler, but at a high level, I can tell you that it exposes the matrix for anyone to understand the consumption levels. And it is available at multiple granularity levels. So what does it mean is that the matrices which are being captured, it is at a process level to start with, then at a container, pod, namespace, and cluster as a whole, right? So you get to see the data and metrics at each level, all the way from process to your entire cluster. There are places where there is an optional module we call the model server, which in short, it has a machine learning module also available baked into it, which can give you, I'm going to talk about that a little later, where how it helps to give you the matrices in a network constrained environments, and for higher accuracy also the machine learning actually kicks in, right? So there's a machine learning module as well as a part of Kepler. So with that, I'll probably go to the next one. You might not be able to see it on the screen, but what I can do is I can highlight and kind of tell you. When you have the copy of it, you can dig deeper. So right on the left side, what you see is basically, this whole, what you see on the screen is a Kepler architecture or the component view. And I'm going to explain you what are the moving pieces there, right? So broadly, you can see the gray part, which is the user space program. So guys who are comfortable with Linux, you're going to be able to understand this. So there is a user space area and as well as a kernel level. Starting from the blue area that you see, this is the kernel level data. So Kepler leverages eBPF programs and K probes to get the hardware counter, the performance matrix out of the kernel directly. Now, this K probe is or eBPF as a whole is a great technology where without reloading your kernel modules, you can still extract debugging data, performance data out of the system. So this is the place where it is responsible to get your CPU frequencies and CPU related data straight out of your kernel. So that's what you see as a blue box here on the leftmost. Now in the center, in the user namespace, user space, we have this green area which what we call as a pod lister is the name of the component there. Which essentially is nothing else but it is trying to extract data from the processes that tries to use your CPU, RAM, GPU and all of that. There are three here which is called out: process info, container info and VM info. So depending on the workload that you're running on the Linux, those data, the metadata is required to be collated. So this green component is responsible to extract PIDs for the processes, container ID for containers, VM ID for the VMs, and pass it on to the next level, right? On third is your red box here, which is nothing else but to get the hardware matrices. Now, what do we mean by hardware matrices here is that so on the left, you actually saw how the CPU, memory, and all of that is getting consumed. By whom is the green one? Red one is all about the energy, right? So I'll give an example of RAPL, which is the first one here, which is hardware monitoring RAPL. The RAPL is nothing else but it's a library which is available, made available by Intel. It started from Sandy Lake architecture first. Now it is definitely available with most of the modern processors. Now RAPL is nothing else but it allows you to read how much of energy consumption was done since that machine was restarted, right? It uses your sysfs and perfstat libraries to extract data straight away. In fact, when I was playing with it, it was very fascinating to see. If you're dealing with the raw data, then sysfs is absolutely the place to go. But if you want to use library, perfstat is equally good to extract data. Now it extracts data at a socket level up to the core level, right? That's one of the examples that I gave. Similarly, you have NVIDIA and Intel GPU APIs also available. In NVIDIA has something called as NVML management library, which it exposes the API to extract the energy consumption by the GPU for running the processes, right?
Yeah.
We're running short of time?
No, it's fine.
Right. So again, the red part is nothing else but it extracts your energy consumption from the platform below. Now all of this data gets aggregated and it marries your process level, process definition with CPU consumption and the energy consumption. It marries together and finally something which is called power model is created. Right? There are places where these hardware details are not available. For example, a virtual machine. A virtual machine, these hardware details might not be present. Or a cloud environment like your AWS and Azure. You may not have access to the hardware directly. So in that cases, it uses something called as estimator matrix. Now, these are machine learning models which are already made available in JSON and in a zip format, tar format as well. These estimators are responsible to give you that data at runtime and finally create a power model out of it. Now, this is at the top. At the end of it, it exports all those metrics in the form of Prometheus matrix. And there is an arrow missing here. What happens is that any component which is on top here can read this data, scrap the data, and create your dashboards and blah, blah, blah all out of it. Or you can create corrective programs like KEDA and peaks, which Shailendra will talk about. Apart from that, the same data is actually fed back into this model. If you are actually deploying the machine learning model, then the data goes back in there for further training. Live training happens every 2 to 3 minutes, and for higher accuracy. So that's also available as a part of this architecture. So I think I've covered a lot in detail, so I won't, so this is just a repeat of that. I think we are a little short on time. So this was just a slide to explain you that if you're interested to understand how the machine learning model is working. So at a high level, I can tell you is that right in the center, there's an optional model server which hosts your machine learning model. And it takes the labeled data out of your Prometheus, all the data that I've spoken so far, and you can run your model in online and offline mode. So there are cases where the systems are offline, it is not connected. So when it is not connected, then in that case, you can use it in offline mode. Data still gets fed into it, the training still happens for higher accuracy. If it is online, then the data, once this training happens, it tends to upload the data back to GitHub and pull, because Kepler has a way of pulling the data back from GitHub and keep it up to date, right? And Power Model is the basis on which Clever or Kepler works, right? So I think this is just another way of explaining how the data actually percolates back to Prometheus. But I think with that, I'll probably switch towards how it actually, you can get started with it. Shailendra?
Okay, yeah, thanks Rajiv. And hearing CO2, carbon footprint, energy, looks like we are back to the college, and yeah, we are at MIT. So guys, I promise you I will not bore you with those, again, the concept and other things. I will just move quickly so that I can show you some demo how it look like, okay? These are some deployment model options when we start working with some enterprise Kubernetes, or you have a edge device where you are running as your telco workload, or you have a RHEL server which is running as a standalone. So these are something on the extreme right. What you see is like Kepler provides an operator, then there are manifest file, then there are RPM. I'm pretty much sure everyone would be aware of RPM, how you do an installation on a Linux or on the RHEL server, okay? Moving quickly, so what we will do, I will just quickly go to the demo part. This is a very high level architecture. For the demo, we are using OpenShift. It's nothing but a enterprise Kubernetes, okay? But the same thing can work on any Kubernetes clusters, okay? So can you open that link? Rajiv, you have that?
The demo part, right?
The console.
You have the password?
Just like.
Okay, so we need to retrieve the user ID password.
Kubernetes. Okay, thank you. I hope the internet is working, so we can just, if you are not familiar with what the screen look like, this is a console which is provided by on top of OpenShift, okay? It's a console where you can manage your Kubernetes. So what I can do, I can go and just show you, there is an operator hub. You can just imagine this as a marketplace where any product which is certified or a community product, what you can see, you can find a lot of community product as well as Red Hat certified. If I scroll down, I can go and just see, okay, whether I need something from Red Hat or which is Red Hat or some other community one, certified community market space, I can go and I can do the search over here. So what I can do, I have to just search for Kepler, and you can see there are two available for installation. One is directly from the Kepler. Another, what you can see is a product version which is supported by Red Hat. It's a power monitoring. Technically, both are same. It just you get a support or you get certified by Red Hat. Okay. So once you click, you just have to do a click. The console made very easy for a developer to install any product or kind of Kepler. So once the installation is done, I can be, okay, there are a lot of operator, where is my Kepler one? Okay, this is the power monitoring which has been installed. What you can do, once you install a product, you do some level of configuration, okay? So the configuration which is mandatory, if you have heard Rajiv explaining the big architecture diagram where it says scrap the matrix. Whenever the matrices are scrapped, you need some port to listen. That is the bare minimum which you need to provide. Okay, this is the port. And this toleration is something where you give a label, like I want to run on each and every node. Okay. So that's where you provide the configuration. Once you do the deployment, what will happen? Automatically a workload as a daemon set, it would be created, a kind of Kepler. And what is the daemon set? It's a kind of one of the deployment model for Kubernetes, which ensure one of the container or a pod will run on each and every node. And right now what I can see, I have a 6 node cluster, which is 3 master and worker. All the 6 pod are up and running. So this is the actual code which is running on my node, which will scrap all those matrices. And what important I can see, those are the logs. If you go and verify, okay, this is what it is using, what are the CPU ID, blah, blah, blah. Okay, this is the Intel Neon Platinum processor which has been used. It will try to fetch everything and it will try to store those to the Prometheus. Okay. So what I can do, I can just quickly go to and just try to show you how the dashboard and everything will look like. Okay. So once you deploy Kepler out of the box or power monitoring by Red Hat, you get our out of the box monitoring setup which is done. This is the overview. This is what it's important, where you can see, okay, what are the architecture, CPU architecture. Not all CPU architecture which has been worked for Kepler, but this is the Cascade Lake, okay. Then the platform shows right now it's running on a cloud, so it's not running on a bare metal where it can be a Dell or some platform, and number of nodes. Now what I can see, the important thing is, okay, what is my total energy conversion, right? You can see from last 24 hours, 27.8 kilowatt hour. Someone from physics can understand, okay, what's kilowatt hour or what's joule is there. Okay. Now I want to understand, if I'm running my workload, which namespace or project, which workload is consuming my top power, and I can see, okay, namespace system and all those things at high level you can verify over here, and then at the node detail. So this dashboard provides you an overview of your cluster at a node level. If I want to go more deep dive, then I have to go in a next dashboard which is available at a namespace level. Now I can see every namespace. Okay, what was there? Now the important thing to focus is this PKG, which is something package, DRAM, other, and GPU. Then you would be thinking, what the hell is this PKG? And that was my first thought when I just saw this dashboard. It's something which consumes the power consumed by your CPU core, which is your socket, and then the non-core. Then what is the non-core? Like L2 cache or your memory controller. All those power consumption are considered in this PKG. If you want to assume like what is my CPU consumption power, is the PKG. DRAM, I am pretty much sure the people would be knowing, it's the RAM, is the memory which you would be utilizing. Other is something like storage, networking, the power utilized by the storage, by the networking, and all those components which will build up your server. Now the other is GPU. Now AI, as a buzzword, everyone would be knowing what GPU is there. If your machine is running GPU, you can see 0 because I'm not running any of my AI ML or any workload on the GPU. It's not providing me. Okay. Now I can see my total power consumption. Now I can see some of the spikes. Okay, this is the spike which has happened. If I want to go and see which workload was there, so I can see this some backend con. So I can identify, okay, it's a con job which has executed every hour, and that's the reason I can see the spike. Okay, so this is the dashboard which would be familiar. I'm just trying to rush to see the timer is also clicking very fast. I'm not sure why, but yeah. So this is something which you get baked inside the console. Now you are thinking, okay, hey, I'm not using OpenShift. I'm using a local Kubernetes which I have deployed. If you have done that, it's just a matrix and Grafana. You can install Grafana. The same dashboard which you are looking over there, you can just see in my Grafana 27.8 kilowatt hour. And if I can see my maximum utilization, yes, is the system namespace. Let me see and compare if that is the true, because I have not seen if that would be the exact, or else you would say, okay, why the Grafana is showing something else? If I just sort, okay, the system is the maximum 4.5, the exact same data you can see over here also, and each and every namespace and every details. Okay. So that's all from a very high level of demo perspective. That's which ends the demo, and then you would be thinking, okay, now I have identified this is something is consuming my power, then what next? How to solve that problem? So this is something which is a takeaway, which you can go back and try to research how we can do that part. There are 3 very beautiful projects in the community: Pix, Clever, and CubeGreen. I'm not going to read over those. The Pix is for your scheduler workload. Clever is if you want to do your horizontal scaling, means if you want to increase your RAM or CPU, that is where Clever you can use, and CubeGreen you can use to control the workload during your peak hour. Yeah, that's all. Thank you. I think we are with 4 minutes left. Rajiv, you want to add something, or we can take some questions?
We can take questions.
Yeah.
If anybody has any questions, let me know.
Is this working?
Yeah.
Yeah, okay. No, I mean, we might have rushed a little bit towards the end because we were running late from the previous one, and then you got started late, so which is okay. I just want to call out that the other projects that was the Clever, I think that's a fantastic new community project, which actually gives the correction to be achieved based on the matrix that is collected. It works on the VPA, Kubernetes VPA, right? Any question?
Hello?
Yeah, you can just repeat your question, please.
Yeah, so this thing is supposed to run only on a bare metal, right?
No. So, okay, I got your question. In fact, there was a slide that I had prepared. I knew that this question going to come.
So to answer in short, no, because the demo which you saw was running on a public cloud on Azure. It was running on a hypervisor. So it's not mandatory for a bare metal. Hypervisor can also work.
Yeah.
Oh, okay, because see, I'll tell you. So if I go to Azure or AWS and I take an instance, okay?
Right.
Azure or AWS is not going to charge me lesser money if I optimize my app. Is that a correct assumption?
I would say it's no, it's debatable. If you optimize your workload, taking the CPU, because they will charge for every CPU, every network, every storage. If you optimize your workload by looking, okay, this CPU is not required for my workload. I can have a lesser machine set, you can say in Azure or in...
Understood.
I'll give you a very lame example just to put that into perspective. You must be using an iron box to iron your clothes, right? Now imagine when you plug your iron box, there is a time when it tries to heat the coil, right? That time the consumption is really high. But then there is a period in which when you're using the box, it doesn't consume any much energy. So I think what you see on the screen is basically a kind of a table created where it clearly maps out at which architecture, whether it's a bare metal, x86 or not 86, if it is x86, then with power meter or not, and it supports VM as well as bare metal, right? The key takeaway here is that if it is bare metal, then a lot of live data is being extracted straight away from the BMC, right? But when you get, in fact, there's a concept of idle power and dynamic power. The system is pretty intelligent enough to extract the data and then allocate it intelligently for each process and container that is running on the system. But when it comes to the virtual machine or VM places, it falls back on the estimator, and that is where you get to see a single number, not differentiating between idle and dynamic power. So there are some nuances is what I'm trying to call it out, but it works in both the places. Okay. And what you need to do is, based on the consumption, you can...
just have a 1 minute, I think one more question.
Yeah.
Okay, thank you so much.
First of all, thank you for sharing this. It's great to know about this operator. So I have a question around the capturing the log error messages, right? Is there any kind of a warning or something like we are getting from this? From this operator mainly towards the like this is the maximum energy consumption you have reached, right, from your particular namespace or overall the total workload which we are running on.
Got your question. So I think in last 25 seconds, you might have seen in the slide that there was a matrix. So there are a bunch of matrix focusing on multiple aspects of it. And right, once the matrices are available, you can build your alert system on top of that, right?
Okay.
So you want to add something to that?
So yeah, rightly said, you can see the matrices over there. The system is Grafana. If you know Grafana, Prometheus Alert Manager, these three is a combination very much popular in a community. If you have an alert manager configured, you can send an email and whatsoever is there. Okay. Yes, it's possible.
Okay, so that means like there's no particular like maximum reachability on the energy consumption for this, but it's based on the like log checking and all. We are getting the warnings, right?
It's depend upon the threshold which you apply. If you say like, okay, my system is taking 4.53 kilowatt hour,
Okay.
which you can see the screen, but I think it should take below 3, I can add a threshold of 3. If it's gone beyond 3, send me an alert.
That's nice. That's threshold we are putting down. That's
Yeah,
great.
yeah. So again, you can actually straight away marry back to the matrices that it offers out of the box. I know we are totally out of time. I'm just showing you these are the matrices, and you can just configure to the thresholds in them, and you can generate alerts out of it. Yeah.
So
And
we are
they-
here
they-
available. If you have any question, we can discuss.
Yeah.
I think there would be a next session going
So
on.
we have to wrap up here, but I think one last statement I want to make is that there's a project called as Cube Green, which is fantastic. Probably I can talk about that a little later offline maybe, which actually mitigates, brings your workload down and reducing the cost. That was the question earlier. Yeah.
Okay, thanks. I think in the interest of time, we'll call this. Thank you for the speakers, for the great talk. But they'll be around, so in case you have more questions, you can always catch up with them offline. We'll get the next talk started in a couple of minutes.